In this video, we'll be looking at solving simultaneous equations using a matrix method. These are linear equations. So we're given the pair of simultaneous linear equations, and we're asked to write the equations in the form ax equal b, where a, x, and b are matrices. Now, how do we do that? Well, let's write A as a matrix. A is actually a 2 by 2 matrix, which means that we'll have 4 components in the bracket in a rectangular array. So we'll have the coefficients of the variables. So we'll have 4, we take the 3 and the 2 as well, and we actually have a number before the y. If you're not seeing a number, it's actually 1. In fact, when we read this, we're saying 4x plus 1y equals 1. 3x plus 2y equals 2. So there's actually 1 there. And what we'll enter in the bracket will be 4, 1, 3, and 2. In that order. 4, 1 goes here, 3 goes here, and the 2 goes here. The matrix X next, which means we're multiplying matrix A by matrix X. So this should be matrix X, which is a capital X, by the way. So you can put it at the top if you want to. But to prevent confusion, if you put A here, you're saying what? That matrix A is equal to this matrix multiplied by this matrix. Because these two matrices next to each other means that we're multiplying matrix A by X. But you don't want to put A here because you'll be saying that A is equal to the product, which is not true. So let's enter the information for this matrix, which is matrix X. Matrix X is the variable matrix. So you want to have the variables inside of it. Now the first variable we put in is the variable X. And the next variable is the variable Y. In this order, it's very important that you put the X at the top and the y below. Again, this is not a fraction. This is just saying we'll have 2 entries. This is a 2 by 1 matrix, 2 rows, 1 column, and it's equal to a constant matrix. And the constant matrix will include the components 1 and 2, or the elements 1 and 2. Again, it's not a fraction. We just have 2 entries for this matrix. So this is matrix B. So all we're saying here, this is matrix A multiplied by matrix X, which will give us matrix B. Please do not put the letters at the side. Next, we're asked to write the inverse of matrix A. Notice that they gave us matrix A, but we actually have that here because it's A times X equal B. So we know matrix A is actually equal to a matrix with components 4, 1, 3, and 2. But now they want us to write the inverse of it. If we have a matrix A and the components are A, B, C, and D, to find the inverse of that matrix, you'll put 1 over the determinant, which means you're going to multiply component A by component D. So that's A times D minus, it's 1 over everything, B times C. Matrix components B times component C. So A times D minus B times C. Now this is not the inverse. This is 1 divided by what we refer to as the determinant. So the determinant of a matrix, which we can use this symbol, these 2 poles to the left and right of A, it means the determinant of A is equal to A times D minus B times C. So what we're doing here is putting 1 divided by this determinant, and then we'll multiply by the adjoint matrix. Now the adjoint matrix, or the adjoint of a matrix, is basically, let's write that, A adjoint. A adjoint will switch A and D, so D will be here, A will be down here. Now B and C will change their signs. So in other words, we'll multiply B by -1, so that will give us negative B. And C will also change its sign, meaning we'll multiply by -1 as well. So let me highlight again. These are the entries in the leading diagonal. We'll switch them. These are the entries in the non-leading diagonal. We will not switch them. Instead, we multiply them by -1. In other words, we'll change their signs. So this is the adjoint matrix A, or the adjoint of matrix A. So we have to remember that the inverse is 1 divided by the determinant multiplied by the adjoint matrix. Let's write the adjoint matrix here and include the components. So this is set up to finding the inverse. This is matrix A and this is its inverse. So given that matrix A has components 4, 1, 3, and 2, we'll do the same thing as we do with A, B, C, and D over here to find the inverse. So let's write that quickly. A inverse, or the inverse of matrix A, is equal to 1 divided by the determinant. Let's find the determinant. It's going to be 4 times 2 minus 3 times 1. It doesn't matter if we say 1 times 3 or 3 times 1 or 2 times 4 or 4 times 2. The important thing is it must be the product of these entries in the leading diagonal minus the product of these entries in the non-leading diagonal. So you must put 4 times 2 first, or the result of 4 and 2 first. We're going to multiply this by the adjoint matrix. 1 over the determinant. Remember, this is what's underneath is the determinant is what is below the division line. And what goes inside of the bracket are the elements for the adjoint matrix. Remember, we take matrix A and we switch these So we're going to have what here? 2 and 4. So these are switched. And these two elements, components, they will be negated. The signs will change. So 1 becomes -1 and 3 becomes -3. Whatever signs they have, when we multiply by -1, they will change. Bear in mind, we can simplify this further. So let's do that. I think it's important that we do that. So let's do that. A inverse is equal to 1 over. Now 4 2's is 8 minus 3, because 3 1's is 3. So this is 8 minus 3. And 8 minus 3 is what? If we say 4 times 2 minus 3 times 1, we'll get 8 minus 3, which gives us 5. So we want to put 5 below here. Okay, so this is something you can just put in your calculator or you do in your head. You don't need to write that down. Okay, in terms of simplifying this, you can just do that in your head or you can just use a calculator and put the answer there. Next, we're going to write the adjoint matrix. So this is 1 over the determinant. So the determinant of A is really 5. Determinant of this matrix is 5. So we put 1 over the determinant times the adjoint. 2, -1, -3, and 4. So we can leave our answer as this. Or, since it wasn't specified, we can actually distribute as well. So we can say A inverse is equal to, we're going to multiply 1 over 5 by 2, which is going to give us 2/5. 1 over 5 times -1, that's -1/5. 1 over 5, or 1/5 times -3, will give us -3/5. And 1/5 times 4 will give us 4/5. So this is the 2 by 2 inverse of matrix A, or we can actually have it as 1 over the determinant times the adjoint. So either way, these two are the same things. Okay. Now, if you were asked to show that A inverse is this, then when you write this down, your next step will actually be to write this. And now they're saying for us to use matrix A inverse to solve for x and y. So how are we going to do that? Before we get there, let's point out something here. You were asked to write the what? Inverse of matrix A. So your answer should just be the inverse of matrix A. You shouldn't solve for x and y. So either this, you're going to write this, or you want to continue and write this. Either way, your answer to this part of the question should be the inverse of A. You should not solve for x and y in this section. So you have to read the instruction at the top. Here they're asking you to write in the form of AX equal B. And this is what we did. This is matrix A, matrix X equal matrix B. So you have to follow the instructions. Alright, so let's follow the instruction and do the next one. Use the matrix A inverse to solve for x and y. So all they're asking us to do is to multiply both sides of the matrix equation by the inverse. Now let's do this. So what we're going to do, we're going to write matrix A, matrix X equal matrix B. And let's write the information. Let's write the coefficient matrix, which was what? 4 goes here, 2 goes there, 1 and 3. I basically reverse this because that's how we got the adjoint, and negate these because I know we did that. So yes, and then the constant matrix will include 1 and 2. So 4 1 3 2, then 1 2, 4 1 3 2, and then 1 2. Okay, so this is the matrix equation. But what we're going to do, we're going to multiply both sides by what? We're going to multiply both sides by the inverse. So you can do two things. You can use this and multiply on both sides, or you can use this and multiply both sides. But tell you what, let's use this to multiply both sides. And afterwards, we'll use this just to show you by comparison that they're the same thing. All right, so we're going to multiply this side over here by the inverse. Remember, the inverse is what? 1 over 5 multiplied by the adjoint. So we'd have switched these, right? 2, 4, and negate these. -1, -3. And then we multiply by 4 1, 3, 2, then x and y in bracket. So we multiply this side, which is the left-hand side of the equal sign. So we multiply this side by A inverse. We also multiply this side by A inverse. So let's write A inverse. This is A inverse. We're going to multiply by the 2 by 1 matrix. Now when you multiply A inverse by the matrix A, what do you get? Remember, the inverse of a matrix times A will give you the identity matrix. And the identity matrix consists of 1, 0, 0, 1. So you can watch the previous videos. In the description, click on the link that says example 1, and you will see how to do this, how to multiply this out. But we know that when multiply the inverse of a matrix by the same matrix, the inverse of A by A, we're going to get the identity matrix. So all we need to do, since we already know what the answer will be, we just put 1, 0, 0, 1. So this will be the answer. This identity matrix is the answer for this portion here. The inverse times A. Then we'll put back the matrix, 2 by 1 matrix, with entries x and y. And then we'll multiply the inverse by the 2 by 1 matrix with entries 1 and 2. Now to do this, I'll leave the fraction, that is the scalar, for last. And then we'll multiply row by column. So now let's do that. Now 2 times 1 gives us 2. Let's do it at the side. 2 times 1, first by first, in other words 2 1s 2, plus negative 1 times 2 is negative 2. So that's going to give us what? That's going to give us 0, because this will be minus 2 is 0. So row 1 times column 1 gives us 1 entry, and that answer is 0. In fact, we can just make this a little smaller. And put the entry 0 here. Then we're going to go row by column. And so we're going to say the same thing. First by first plus second by second. So first by first be negative 3 times 1, which is negative 3, plus second by second, 4 2s, that's 8. And of course, the signs of difference, we subtract and keep the sign of the 8, which is positive. The important thing is to know that we multiply row by column, we get 1 entry. And since we only have 1 column, we move to the next row. So this row times this column gives us 0. This row by this column gives us 5. Now we can simplify this side, can't we? All right, so let's do that. Now we know that when we multiply the identity matrix by any matrix, we'll get back that matrix, because the identity matrix behaves just like 1. Okay, so let us just show you how that's the case. Let's go. This is row 1, this is row 2. We only have 1 column. So 1 times x give us what? X, plus 0 times y give us 0. Then go down to the next row. 0 times x give us 0, plus 1 times y give us y. And of course, x plus 0 is x. 0 plus y is y. So you notice multiplying the identity matrix by the variable matrix, we get back the variable matrix. So it behaves just like 1. So if we put 1 here instead of this, 1 times this variable matrix gives us back the variable matrix. So the identity matrix behaves just like 1. So we did not need to multiply this out. We know that multiplying the identity matrix by the variable matrix will simply give us the variable matrix. All right, let's simplify this part. Now we can also do that as side work. So what is 1/5 of 0? 1/5 of 0 is 0. Any number times 0 is 0. So what will happen here? When we multiply 1/5 by 0, so in other words, this is exactly what happens. Now I noticed that in the test that some person, after multiplying 1/5 by the entry, they put back the 1/5. No. In fact, what you're actually doing is this, saying 1/5, you put it inside now, times 0, and then you say 1/5 times 5. So it's no longer outside. And so what you get is 1/5 of 0, which is 0, and 1/5 of 5 is 5 over 5, which is 1. So x is equal to 0 and y equal 1. These are your solutions. Now let's double check to make sure they're correct. X equals 0 and y equal 1. Let's see if that works. So let's see. X equals 0. So 4 times 0. We know that y is equal to 1. So let's put 1 there. 4 times 0 gives us 0. 1 times 1 is 1. So the answer is 1. Let's try 3x. So 3 times 0 plus 2y. 2y is actually 1. This cancels out since it's 0 as 0 and 2 1's 2. So we got the same answers. Okay, good. So we know that those answers are correct. So the answers are x being 0 with y equal positive 1. Now we did say that we're going to use this inverse. So let's do that as well. So you can see how we actually do that. So all we need to do is to erase this. So remember, this is the same as this. So we can just rewrite this without the 1/5. In other words, the 1/5 multiplies 2, multiply -1, and so forth. So in fact, what we have is just the 2 by 2 matrix there, which is 2/5. It contains 2/5, -1/5, -3/5, and 4/5. All right, and this is going to be what? Let's replace the same inverse there with the 2 by 2 inverse, 2/5, -1/5, -3/5, and 4/5. So what we're going to do next, let's erase. Well, we don't have to erase what we have there. We can actually just show you how we end up with the same answer. All right. You can just use your calculator and do row by column, and you actually get positive 1. So we can actually demonstrate that briefly, so you can see how that's the case. But remember, in the exam situation, you're not gonna work that out, the left hand side. You know that what? You know that this is the inverse of A, and this is A. When you multiply these two matrices, you're gonna get the identity matrix. So you just need to put that. You don't need to work it out. You already know that's the case, but I'm just showing you in this video example why that's the case. So 2/5 multiply 4 plus -1/5 multiply 3. All right, so let's go. 2 4s 8, that's 8/5, because 5 1's 5. And okay, put the plus here. -1 times 3, that's -3. And 5 1's 5. Now the denominators are the same, so we keep the denominator. I'm going to say 8 plus -3. This is going to be minus. 8 minus 3 is 5. And 5 into 5 gives us 1. So we see how we got this 1 here. 1 row by 1 column gives us 1 entry. Now we do the same thing for, let's do row, okay, same row 1, but this time by row 2. Go over that again. Same row 1 by column 2. So we're going to say what? Let's look at it. We're going to say 2/5 multiplied by 1 added to -1/5 multiplied by 2. Again, you can do this with your calculator. No need to be writing all this down in an exam. You can just plug this in your calculator, especially if you can store the input. All right, so 2/5 times 1 is still 2/5 plus -1 over 5 times 2. -1 times 2 is -2, and 5 times 1 is 5. All right, so we have same denominator, and we're going to have 2 plus -2. Now it's going to be 2 minus 2, which is 0. And 0 over 5 is 0. So that's how we get this entry here. So it's row 1 by column 2. Our answer goes into row 1, column 2, which is here. So if we go down now to the next row, and we say -3/5 times 4 plus 4/5 times 3, you'll get 0. Row by first column, second row by first column, so our answer goes into the second row, first column. And if you say now row 2 by column 2, this should be a 1 right here. Looks a little strange, but it's a 1. You'll also get the 1 here. But again, you don't need to do this working. As I said, you should know that when multiplying an inverse by the matrix, you get the identity matrix. So this is just to show you. But you can also watch example video 1. Just click on the link in the description. When you multiply this identity matrix by this, you're going to get the matrix itself. Remember, in previous alternative method. And also, for this side here, let's work out this side, because we did change the appearance of the inverse. So let's look at that. So for this side here, what we'll do is to multiply row by column. So we're saying 2/5 first by first, so 2/5 times 1 plus negative 1/5 times what? 2, second by second. Now, of course, 2/5 times 1 is still 2/5 plus negative 1 times 2 give us negative 2. 5 ones 5. Keep the denominator. 2 plus negative 2, that's 0. So our answer will be 0. So row by column, 1 row by 1 column give us 1 entry, that's 0. We don't have any more columns, so what we'll do, we just go down to row 2, which is down here, and multiply that. Again, you can use your calculator if you can store the inputs. So that's important, so that you don't waste time. So negative 3/5 times 1, first by first, added to 4/5 by 2, second by second. So negative 3/5 times 1 is negative 3/5. And 4/5 by 2, so 4 2s 8 over 5. Keep the denominator of 5. Negative 3 plus 5, that's 5. And 5 and 5 goes once. Get 1 there. Now remember, when you multiply identity matrix by matrix, you get back the same matrix. And that's going to be equal to the matrix with 0, 1 as components. These are equal matrices, and you know that when you have equal matrices, corresponding entries are equal. So we do that x is equal to 0 and the y is equal to 1. And we already went through why this is a correct solution set, as in x equal to 0 and y equal 1. We actually went up and plugged these values in both equations, and we got the respective answers 1 and 2. Okay, hope this was helpful as to the different ways you can actually structure your solution. Have a good evening.